Hi students, let us continue the problems. Exercise 6.1. Next problem is in the exercise 6.1, that is 12.1 is the radius of an air bubble is increasing at the rate of 1 by 2 centimeter per second. At what rate is the volume of the bubble is increasing when the radius is 1 centimeter? Radius of air bubble is that. Air bubble is nothing but in a previous video you have seen that the gas is pumping inside the balloon. The same type of the problem is that. Air bubble is that. Suppose the air bubble is that. In that the radius of the air bubble is given. What is the radius bubble? Radius of the air bubble is increasing. That means rate of change of radius of the air bubble is given. Per second is that, so dr by dt 1 by 2 centimeter per second. Dr by dt because rate of change of increasing at the rate is that, so dr by dt is equal to 1 by 2 centimeter per second. Next, at what rate is the volume of the bubble is increasing? At what rate the volume of the bubble means we need to find that dv by dt is equal to how much whenever the radius is 1 centimeter. Previously they have given a rate of change of volume. Now just found out the rate of change of radius. Here rate of change of radius is given. We need to find that rate of change of volume. Once again the same thing, we know that the volume of the sphere. What is the volume of the sphere? 4 by 3 pi r cube. Differentiating with respect to the time. If we differentiate with respect to the time, what will get? dv by dt is equal to 4 pi by 3 constant or a coefficient, keep as it is, into 3r square into dr by dt. Here 3 get cancelled. We need to find that dv by dt is equal to 4 pi as it is r square value. Whenever r is 1 centimeter, is that 1 square is 1 into dr by dt is 1 by, that means 2 ones are 2 twos are, finally 2 pi is left. So dv by dt, rate of change of volume of the air bubble is 2 pi. What is the unit? Pi r cube is 4 by 3 pi r cube. That means centimeter cube per second. This is the required value. Okay. Now the next problem is, yes, next one, 13. A balloon which always remains spherical has a variable diameter 3 by 2 into 2x plus 1. Find the rate of change of its value with respect to the x. Okay. A balloon is that. Again, previously you people have seen two problems. Balloon is that which always remains spherical, has a variable diameter. In a previous two problems they have given a variable radius, but here they have given a diameter. Variable diameter is given. Already know that diameter, that is d. D is equal to 2 times of the radius. This passes a line segment which is passes through the center of the circle. Okay. Diameter, variable diameter is given. That means diameter value is given. The diameter is equal to 3 by 2 times of 2x plus 1. Then find the rate of change of its value. We need to find that rate of change of its value with respect to the x. Previously they used to ask that find the rate of change of its value only. We used to take that depending upon the given unit, given rate of change of quantity with respect to the time. But here the diameter is in terms of x, and we have to take that. They only mentioned that value with respect to x. So it is sufficient to find that dv by dt is equal to how much? dv by dt is equal to how much? Then how to find that? Already rate of change of value we need to find. But we know the volume formula. What is the volume formula? 4 by 3 pi r cube is that. They are not given a radius. Is it possible to find the radius value? Yes. How to find the radius value? Radius value you can write diameter divided by 2. Therefore, radius is equal to diameter divided by 2. This whole quantity divided by 2 is nothing but 3 by 4 into 2x plus 1. This is the radius value. Now replace it here. Now the value is equal to value 4 by 3 5. R cube is that. So R cube is R is nothing but 3 by 4 into 2x plus 1 whole cube. So now replace it. 4 pi by 3 into cube. 3 cube is 27 divided by 4 cube is 64 into 2x plus 1 whole cube. I just replace that directly here because you might have asked the question that don't replace the radius value here. After differentiating, we can replace it. So what happens? Problem is here if you differentiating with respect to time dr by dt. Here I am just need to differentiating with respect to x. So that I am just know that r value in terms of x. It is sufficient to replace the r value after getting. How many variables are here? Only the one variable, left hand side value. Now, if you differentiate with respect to x, you will get the required rate of change of value. So simplify. Here 3 ones are 3 cube 27. Instead of writing this one, I just write 3 into 3 into 3. 4 cube, instead of writing 4 into 4 into 4. None of them the same. 1 after 3 get cancelled. 1 after 4 get cancelled. 3 3 is 9, 4 4 is 16. 9 divided by 16 will get. So value is equal to 9 pi divided by 16 into 2x plus 1 whole cube is that. Now here differentiating with respect to what? Differentiating with respect to x here. If you differentiate with respect to x, what we get? dv by dx is equal to 9 pi by 16 is a coefficient, keep as it is 9 pi by 16 in 2x plus 1 whole cube is that. Again here chain rule we have to apply. So 3 into 2x plus 1 whole square in place of x 2x plus 1 is that. 2x plus 1 differentiation is 2. Are you clear? Yes. 2x plus 1 differentiation is 2. X power n differentiation first and afterwards in place of x 2x plus 1 is the differentiation that value into. Now simplify. So what we get? dv by dx is equal to 9 pi by 16 is that. So I just write 9 into pi into 3 divided by 16 as it is into 2 is that. So into 2 as it is at the beginning. Okay, we can cancel it, no problem. Into 2x plus 1 whole square. So 9 pi by 16 into 3 into 2 and 2x plus 1 whole square. Now we can cancel. 2 ones are 2 8s are 16. So 9 3s are 27 pi divided by 8 into 2x plus 1 whole square. This is the dv by dx. Now again afterwards you can simplify. dv by dx is equal to how much it is? 27 divided by 8 is that. We can cancel it or keep as it is, doesn't matter. So if you want to simplify means decimal value will come. Decimal value is 8 reason 3 point something value will get it. So instead of keeping that we can write 27 by 8 into 5 into 2x plus 1 whole square. What will be the unit? Rate of change of value with respect to x is that. Already diameter in terms of x is that. So what we can write? Cubic unit per unit. So unit cube per unit. Unit cube per unit. If the given in terms of centimeter, centimeter cube per, it is not per second, it is per centimeter only. Centimeter cube per centimeter because I am just differentiating with respect to the x. So diameter is the length, that is nothing but diameter divided by 2. Radius value in terms of x is that. So that reason it is unit cube per unit. Now the next problem is 41. Sand is poured from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone is increasing when the height is 4 centimeter. Very important for the examination part in 5 marks session. Okay, solution. Here, cone, regarding the cone, how it forms a cone, let's have a look. Sand is pouring from a pipe at the rate. Suppose a pipe is there. From this pipe, the sand is flowing. A sand is falling on the ground. It forms a, what is the shape it forms? It forms a conical shape. Forms a conical shape. They only given that a sand is pouring from a pipe at the rate of 12 cm per second. The falling sand forms a cone. Falling sand forms a cone. This is the height and this is the radius of the base of the cone. Falling sand forms a cone. Before that, sand is pouring from a pipe at the rate of 12 cm per second. What is this value? 12 cm per second. Centimeter cube per second is that cube is nothing but volume. Whenever sand forms a cone, the rate of change of the volume of the cone is given. That is rate of change of volume with respect to what? Per second is that with respect to the time. dV by dt is equal to 12 centimeter cube per second. Value is given. Then the falling sand forms a cone on the ground in a such a way that how this cone is formed means in such a way that the height of the cone, the height h of the cone is always 1/6 of the radius of the base. Radius of the base is here. Height is given. Height and radius, there is a relation. How the height and radius are related? Height of the cone is always 1/6 of the radius of the base. Height is 1/6 of the radius of the base. Height is 1/6 of the radius of the base. Is that okay? Height is 1/6 of the radius of the base. Suppose if radius is 1 unit changing, then height will be changes as a 6 unit. Cross multiply, r is equal to 6h. So if the radius is changing 1 unit, the height will be changes as a 6 unit. This is the meaning. Height of the cone is always 1/6 of the radius of the base. Next, how fast is the height of the sand cone is increasing when the height is 4 cm? What we need to find? How fast is the height of the sand cone? How fast is changing? That means the rate of change of height with respect to time is equal to how much? Whenever height is 4 cm. Whenever height is 4 cm. If h is 4 cm height, then what is the rate of change of height of the sand cone? We need to find. Okay, read the word problem and according to that we have already written given thing and what we need to find. From this we need to find. So already we know that volume of the cone. What is the volume of the cone? Volume of the cone is 1/3 pi into r square into h. Are you clear? Volume of the cone is 1/3 into pi r square h. Here r and h are the variable. If radius and the height of the cone is changing, the volume of the cone is also changing. That means the radius and the height are the two variable. Convert into single variable. How to convert into single variable? Either the volume of the cone in terms of r or volume of the cone in terms of only the h. So how to change? Using this relation. Which value we are going to replace? Yes. Here we are going to change the either h value or r value. If we replace the h value in terms of r, what happens? This is h value in terms of r, 1/6 into r. R into r cube will get. Then reverse differentiating with respect to time, dr by dt will get. But we don't have a dr by dt in the given data. So that reason, instead of replacing the r value H value, better to replace the R value. What is the R value? R value is calculated as R is equal to 6 into H. So after replacing the R value as 6 into H, what happens? R square. 6 into H whole square. That means 6 into H whole square into H. Value is equal to 5 by 3 into 6 square 36. H square into H is H cube. So 3 ones are 3 12s are. So value is equal to 12 pi into H cube. Now here, if you differentiating with respect to time, we will get the required value. What will get? Differentiating with respect to time. dv by dt is equal to 12 pi as it is coefficient. H cube differentiation is 3 times of H square into dH by dt. Now simplify. What will get? 12 into 3, 36 into 5 into H square into dH by dt. So already know the dv by dt. What is the dv by dt? It is a 12. So here we can cancel. 12 ones are 12, 3s are 36. Stripping all these values because we need the dH by dt value. What is the dH by dt? dH by dt is equal to 1 divided by 3 into pi into H square. So already know that H value dH by dt. dH by dt at H is equal to 4. At H is equal to 4 is equal to how much? 1 divided by 3 into pi into H square. H square is nothing but 4 square. Simplify. So dH by dt is equal to 1 divided by 3 into pi into 4 square is 16. 16 into 3. 16 3s are 48. 48 into pi. This is the dH by dt. So dH by dt is equal to 1 by 48 pi. What is the unit? Unit in terms of centimeter is that, so that centimeter per second. And the solution. So rate of change of height of the sand cone is 1 by 48 pi centimeter per second. And no need to simplify this value. Replacing pi value as 22 by 7. Simplifying, no need, keep as it is. After replacing or simplifying, decimal value is 0.03 something value will get it. That's not enough, we can keep as it is. Okay. Now, next product is, the next product is the total cost C of x. The total cost is given denoted by C of x in rupees associated with the product of x units of an items is given by C of x is equal to 0.007 into x cube minus 0.003 into x square plus 15x plus 4000. Find the marginal cost when the 17 units are produced. So it is problem comes under the production unit. So how the sum of the items has been produced. For example, a choppies is produced or dusters or a board like that, and the several items are there produced, or a pen like that, or a book. This type of functions or this type of the items has been produced in that. The cost function is given. One item, the cost of the choppies depends on, or the cost of the item is given in terms of the number of units has been produced. Product of x unit is that. So number of units. Based on the number of units, the cost function is given in this manner. Now we need to find that what is the marginal cost. Whenever if you want to produce a single choppies, it is same, and as well as if you want to produce 100 choppies. Which one is easy? Producing a single choppies and producing the 100 choppies. A difference is that if you produce the number of items more, then the effort will be less and cost will be less. So that reason, as compared to that one, so that reason they are producing the 17 units. So that cost function of producing the x items is given. Now what is the marginal cost? Marginal cost means in a shop there is a particular rate will be fixed. That marginal rate will be fixed. That marginal cost we need to find. that marginal cost depends on the number of units we have produced. Marginal cost depends on the number of units of items have been produced. So that C of x is 0.007 into x cube minus 0.003 into x square plus 15x plus 4000 is that. Okay. Now if it is a cost function, if I differentiate, that will get the marginal cost with respect to the x. Differentiating with respect to x, that will get the marginal cost. Marginal cost is given by m of x. Differentiation of c of x with respect to x. What will get 3 into 0.007 into x square minus 2 into 0.003 into x plus 50. This is the marginal cost, and particularly they are given how many units of items has been produced. 17 units of items has been produced. So m of 17 or c dash of x at x is equal to 17. What will we get? So this is 0.021 x square minus 0.006 x plus 15 at x is equal to 17 is that. So marginal cost at the x is equal to 17 units is 0.021 into 17 square minus 0.006 into 17 plus 15. And after final simplification, how to simplify this finally? 17 square into 0.021 minus 17 into 0.006 plus 15. Then the final answer is 20.967. The marginal cost of producing the 17 units with respect to the cost function is this one is 20.967. Okay, with this problem it completes the application of derivative. That is one of the next application of derivative is completed, that is rate measure. Totally in so far we have just completed the 3 applications. One is the increasing, decreasing and approximation, and next one is rate measure is completed. The next 2 applications are there. One is tangent and normal, another one is maximum minimum. In the next video I am just going to start with the tangent and normal. To learn the tangent and normal, you should have basic idea about the first PUC straight line chapter. What is the straight line? You have already know that. And what are the concepts you have just learned in the straight line? Different types of the straight line equations we have just studied, and how to find the line equation depending upon the given condition. Whenever the point and the slope is given, whenever 2 points is given, whenever and y-intercept and the slope is given. Similarly, x-intercept slope is given. Whenever 2 intercepts are given, whenever and normal form is there, and distance between the parallel lines, distance of the point from the line, and condition of parallelism, condition for perpendicularly. Like that, the several concepts regarding the lines people have studied in a previous year, first PUC. So it is just better to recall all those concepts, because if you know that straight line concept very clearly, then you can easily learn or easily come to know that what is meant by a tangent and normal. So we'll continue the next application of derivative, tangent and normal, in the next video. Okay, thank you.